Okay, here we go. Warning in advance that my son is now awake and he's playing his RL mod in Minecraft, which is apparently pretty hard. And so if he gets killed, he might start screaming. Just letting you know in advance. It might wake you up. Might wake up the Colorado guys. I don't know if you're asleep or not. Everyone's got their cameras off again. Anyway, I'll assume you're there, and I'm talking into the wind, but that's okay. So what we're going to do is we're going to use this formula here on an example, and then talk about homework if you have questions. So here's the example. So find the length of r equals 2 minus 2 cosine theta, and I'll just say all the way around here, 0 to 2 pi. So it looks slightly different. It looks, instead of having ones here and here, we've got twos. So it turns out that it is the same thing as the cardioid. It's just double the length on those points. So, and because it's minus, instead of it opening this way and dimpling, it opens the other direction. So it looks sort of roughly like that. So you want to know the arc length all the way around this point over here, again, is -4. So if I wanted to guess in advance what that length is, well, if I tried to put a circle in there, then that circle would now have radius 2. So if I did the circle length, that would be the circumference. And so I would have 2 pi times the radius. And the radius is 2, so I would have 4 pi. So I'm going to guess that the answer is bigger than 4 pi. And 4 pi is around it's close to 13. So 12, almost 13. So the answer is going to be bigger than 13. But hard to say if it's going to be much bigger than 13. So I think it's always good when you do this, you get answers out and you're like, the answer was 500, and you're like, yeah, I think it was supposed to be closer to 13. Then you can sort of you can check yourself just doing that. Anyway, in order to do this, I know that I'm going to need r prime, so I can go ahead and do that derivative here. So if I take the derivative, I get 0 for the 2. Take the derivative of the 2 cosine, that will become 2 sine. It's negative before, but it's cosine, so the derivative will be positive. So then according to the length formula, the length is just the integral from 0 to 2 pi of the square root of each of those guys squared, so 2 minus 2 cosine theta squared plus 2 sine squared d theta. And that's the setup. It's just r squared and r prime squared. I think probably I had them in reversed order, but it doesn't matter because they're both squared and both added. So that's the formula for the setup. The rest is now, can you figure out what that integral is? So let's go ahead and do that. 0 to 2 pi. Square roots are always annoying, so hopefully we're going to be able to get rid of that in some way. If I was to square this one out here, let's see. That would be 4, square that one. The middle term is 4 cosine with a minus, so I double that. So that's minus 8 cosine. I get the last term squared, would be plus, because I square out the minus, cosine squared. So just the basic squaring of that, remember in the middle term. And then square sine, so that'll be 4 sine squared. So that's just multiplying the inside out. Now it looks worse, but again, these two terms here, 4 cosine squared and 4 sine squared. If I factored out the 4, cosine squared and sine squared would be 1. So I basically get 4 copies of 1 there. So that part right there is just 4. So if I get Integral from 0 to 2 pi. I'll have the square root. The 4 and the 4 gives me 8 minus 8 cosine theta. So how do I do that? Well, maybe not too surprising. I need another trig identity. And this one is actually the half angle formula, which says that 1 minus cosine theta is equal to the sine of theta over 2 squared. Almost. It's equal to twice that. So it's technically like the double angle formula if this was theta and this was 2 theta, or you can think of it as the half angle formula. So 1 minus cosine theta is equal to twice sine squared. And that's good because whenever you have a square root, you'd really like the inside to just be a square, so the square and the square root can cancel each other out. You have to be a little careful on plus or minus square roots, but if the inside is a square, that is super nice. So this identity is just a half angle formula. And so if I multiply everything by 8, I could get this. So I get 8 minus 8 cosine theta is equal to 16 sine squared of half of the angle. And so now I can just substitute that in for my square root. So I'll get 0 to 2 pi, the square root of 16 sine squared of half of the angle. That looks a lot nicer. That definitely looks a lot nicer. It looks like square root of a square. Now, I'm just going to put a little star on this to say sometimes you have to be careful if you take the square root of a square. Sometimes it's the positive square root. Sometimes it's the negative of that, depending on what the value is on the inside. Now, the nice thing is sine of half of the angle. If you plug any angle between 0 and 2 pi into that function, sine of half of the angle, then the angles are now going from 0 to pi because I'm taking half of them. Half, let's see, the sine from 0 to pi, all those values are positive. So everything that's squared is positive. We don't have to worry about any negatives, so that when we do this, we don't have to worry about putting in pluses or minuses. I can take the square root of 16 and get 4. I can take the square root of this and keep it as sine of theta over 2. And all is well. I think sometimes when you work some of these problems, you'll be like, I worked it out. I took the square root and I got that the length was 0. And the answer is usually because half of the time that thing was positive and half of the time the thing was negative. So you ended up putting them together and they canceled each other out. And it's hard to know exactly where that's going to occur, but I'll just point out that you may have a problem where this length turns out to be 0. So you need to go back and look at your assumptions on this step here. And we can work through that together. So at least, wow, I mean, all this junk expanded out, got condensed, trig identity, and now we're down to here. So the setup is super easy, but the manipulation is tricky. So if I were to then actually do this integral, I would get minus cosine of theta over 2. And then I got to figure out, let's see, if I was to take the derivative, I'd multiply by a half. But instead I have to divide by a half, which is the same thing as multiplying by 2. So I technically have minus 8 cosine. And you can, again, verify that by just taking the derivative of this. Yeah, you'll have cosine becomes sine with the minus goes away. And then I multiply by half to get the 4 from the 8. So that's the integral of that one, between 0 and 2 pi. Now all I got to do is just plug in the bounds. So if I stick in 2 pi, then it gets divided out by 2 to get just pi. Cosine of pi is -1. Multiply that by -8. The first part is 8. and subtract, plug in 0. So I plug in 0, I'll get the cosine of 0, which is equal to 1. Multiply that by -8, I get -8, and it gets subtracted off. So 8 minus a -8, and I get 16. And so the length of that curve, remember if I put in the circle, we guessed it was around maybe 12, 13, somewhere in there. This is slightly larger as 16. It's kind of crazy that we have this weird shape, and it turns out to be an even number of just straight up 16. But with all these pi's and sines and half angles and stuff, the answer is just, no, the answer is at 16. It's a nice answer. I don't have any pi's or anything in there. So sometimes things work out nicely. So that's basically that section. So slope, area, you might have area between two curves, so you're going to have to do some subtraction of two areas like you did in Calc 2. The length, maybe you don't do the whole length, you only want part of it, so make sure you get the bounds correct. But you'll see that stuff as you work through those homework problems. So we came in under 56 minutes here. Try to spend usually about an hour on new stuff and an hour on homework. So if you guys are still there, not hiding behind empty cameras, and I'm happy to answer any questions you guys have on homework.